In this video, we are going to talk about residuals, and residuals are part of line of best fit, so it's still along the same topic as what we've been doing. Let's do an example together. The height h in centimeters of a certain plant t days after it is planted can be best described by the linear model h equals 1.2 t plus 0.14. If the plant's actual recorded height was 6 centimeters on day 5, what is the residual? So just as a reminder, the residual is the actual value minus the predicted value. So first we need to know the actual value. Well, we're told the plant's actual recorded height was 6 centimeters on day 5. Then we need to know the predicted value. And we find the predicted value by looking at the line of best fit. So the line of best fit is h equals 1.20 t plus 0.14. So the predicted value, or the predicted height, on day 5 would be 1.20 times 5 plus 0.14. So we would simplify that. And in Desmos, I'm going to type in 1.20 parentheses 5 plus 0.14, and that gives us 6.14. So the actual height was 6 centimeters on day 5. The predicted height was 6.14 centimeters on day 5. So what's the difference there? So we're trying to find the residual. So the residual is the actual value, which was 6, minus the predicted value, which was 6.14. Okay, so 6 minus 6.14 is negative 0.14. So what this tells us is that the plant was predicted to be 6.14 centimeters, but it was only 6 centimeters in reality. So that plant was 0.14 centimeters less than, because it was negative, it was 0.14 centimeters less than what it was predicted to be. In example 2, Anna is studying body proportions for a science project. She measured the height and the head circumference of 10 people in her class. The results are shown in the table below. What is the residual for someone with an actual height of 66 inches? So here we're told that we're looking at the actual height of 66 inches. So in our table, the actual height of 66 inches goes with someone who has a head circumference of 9.5 inches. So what this is asking us is, when someone is 66 inches tall, what is their predicted head circumference versus what this person's actual head circumference was? So the actual head circumference is 9.5 inches for someone who is 66 inches tall. So we want to know what is the predicted head circumference for someone who is 66 inches tall. So to find that out, we're going to have to find the line of best fit. So we need the y1 squiggle mx1 plus b for this table. So we're going to put this table into Desmos. So once our table is in Desmos, then we can tell Desmos we want the line of best fit so that we can predict the height of, or so that we can predict the head circumference of someone who is 66 inches tall. So we've got y1 squiggle mx1 plus b, and our m is 0.16. It doesn't say how to round, but 2 decimal places for now is okay. And our b value is negative 1.2. So our equation for the line of best fit is y equals 0.16x minus 1.2. So we want to know if someone is 66 inches tall, or in other words, if x is 66, what is their head circumference? So y equals 0.16 times 66 minus 1.2. And we'll plug that into Desmos. 0.16 parentheses 66 minus 1.2. And that gives us 9.36. So our predicted head circumference is 9.36 inches for someone who is 66 inches tall. Now we can find our residual. The actual was 9.5. The predicted was 9.36. And when we subtract those, we are going to end up rounding to the tenths place because there's only 1 decimal place in our answer choices. Whoops. So that gives us 0.14, which would be about 0.1. So what this means is that the actual head circumference of someone 66 inches tall was about 0.1 inches more than expected, because this is a positive 0.14. Then that person was about 0.1 inches greater than the expected head circumference of someone with a height of 66 inches. In example 3, the table represents the time y in seconds that it takes a runner to complete a 50-meter race after X weeks of training. So just think about, in general, if you're practicing for running a race, the more you practice, the less your time should be. So just keep that in mind as we are going. So if this table is modeled by a linear function, what is the residual for this runner's time at week 2? So at week 2, the actual time is 8.7 seconds. So it took him 8.7 seconds at week 2. We want to know what's his predicted time, or what is his predicted number of seconds at week 2. And we find that out by using the line of best fit. So to find our line of best fit, we're going to add this table into Desmos. Just be careful, make sure that you're putting in the correct X and Y values. All right, so once our table is in, we tell Desmos we want a line of best fit, y1 squiggle mx1 plus b. So our line of best fit would be y equals negative 1.98x plus 12.92. So we want to know if x is 2, so if we're at week 2, what is the time? So we're going to plug in 2 for x. All right, now type that right into Desmos. Negative 1.98 parentheses 2 plus 12.92. So that gives us y equals 8.96 seconds. All right, so now we can find our residual. So the actual of 8.7 minus the predicted of 8.96. Think about what this means for a second. After 2 weeks, it was predicted that he would run that 50-meter race in 8.96 seconds, but he actually ran it in 8.7 seconds, so he was faster. That's good. All right, so if we subtract these, 8.7 minus 8.96, that gives us negative 0.26. So that means that his time was actually 0.26 seconds faster than expected. In example 4, this question is posed a little bit differently than the previous ones. It says a scatter plot for Deanne's race times and weeks training are displayed below. So instead of being given a table or an equation and some values, we have just the scatter plot. So we're asked, in what week was Deanna's time closest to her time predicted by the line of best fit for the data? When you're looking for the time that's closest to the predicted time by the line of best fit, you're really looking for which x value has the smallest residual. And I can show you how to find residuals in Desmos. Another way of asking that is which point is closest to the line of best fit. So all 3 of these questions are asking pretty much the same thing. They're just asked in a different way. So first, let's put this table of values into Desmos. So these are your actual values, the ones that are given to you on the graph. All right, so I'm going to zoom out in Desmos until we can see those points. There they are. And I'm also going to tell Desmos to give me the line of best fit. So from here, what we're looking for is which one of these points is closest to the line. So if I were to draw the line kind of how I see it in Desmos, I can see that the closest point is this one here, 859. 1616 is pretty close, and 651 is pretty close, but we can definitely tell that 859 is the closest. So that's going to be our answer, but I want you to understand why that point is so close to the line and how that ties in with residuals. So in Desmos, you have the residuals plot. So when you click E1, look, notice what happens with the table. It gives me some new values. So this E1 is my residuals. So the residual for the first point is negative 6.3 if we're rounding to the nearest tenth. Then we have 3.7, 9.8, and negative 7.2. So the closest point to the line, again, we said that that point that was closest is definitely this point, 859. So that's in week 8. So our answer, we already said, was going to be 8 because that's the point that's closest to the line. And the residual also tells us that because the residual that has the smallest value is 3.7, which goes right with the point 859.